Um, but I've always had an issue. People say, well, if something stinks, breathe through your mouth. Um, the problem is then whatever odor it is you're trying to avoid is now going into your mouth, and you're tasting what you are avoiding smelling. That's more psychological on my point or part, but anyhow. Okay, so the way we smell, the way we're able to detect odors is that we inhale vapors of things that have been um, airborne. And these particles, when they go into our nose, there's a mucus lining in our nose, and the mucus that is in our nose helps us or helps dissolve the particles into smaller pieces. And then they go into what is called an olfactory receptor. Now, for some items, lavender in particular, they talked about it takes up to 7 molecules for you to be able to smell the smell of lavender. So, it's just kind of an interesting little article. And once you recognize a scent, it's kind of like filed away in your brain and it's categorized. So there was a form that I asked you to fill out or do. I think I asked you to do it. And it was basically for you to smell a variety of different things. Were any of you able to get any of those items and try smelling them? Okay. So what I got right here is this brown liquid. This is vanilla, and you smell it, and everybody's going to interpret smells a little bit differently. But when I smell it, I smell to me, it smells like candy, or actually smells like coffee creamer. Um, I drink vanilla caramel creamer in my coffee. Um, it reminds me of baking. You know, that's one of the things it asked you was, what does it remind you of? Go ahead, and those of you who smelled vanilla, or if you can even think of what vanilla smells like, what does vanilla remind you of when you smell it? We got brown sugar. Just know there's actually a lot of people who have lavender in their house because lavender is something that relaxes you. And in this day and age, a lot of people have essential oils they use. So Alexa, vanilla smells like cough medicine, ice cream. Lillian says same. Is that to ice cream or is that to cough medicine, Lillian? We'll come back and talk about that in just a minute, Avinash. So, what in the world? Who is that with the dog? That's Rochelle. Your name was covered up, so I didn't see who that was. Okay. Okay, so then the next one is vinegar. Vinegar, very bitter smell. It actually, to me, it's kind of pungent. I do not like the smell of vinegar as I smell it again and again. Um, so we have rotten eggs, sour. No, Shrag, this is not for a grade. Sorry, Rochelle. So what I always think of when I smell vinegar, and again, this is I guess it's kind of a religious thing, but I always think of Easter and Easter eggs. Because if you've ever made an Easter egg, you use vinegar for the colors. You get a little cup of vinegar and you put a little tablet in it, it dissolves, and then you drop the egg in there, and that's what gives the eggs those colors. Um, Something that's also kind of cool, chili vinegar. Oh, it's a type of vinegar, chili vinegar. Okay. Something that you can do at home if you have not done this is kind of interesting, is get yourself a cup of vinegar and put an egg in it. Let the egg sit in there for a day or two and look what happens to the egg. It's called the invisible egg. It'll actually dissolve the shell of the egg, but the egg won't spill out. The membrane will stay intact in there. Has anybody here ever done that? Saw it on TikTok. Everybody sees things on TikTok. Yeah, like I said, just get yourself a cup. It's best to use white vinegar, the clear vinegar, and you make sure the egg is completely submersed in the vinegar. And it takes a couple days. It takes at least 24 hours, but I think it took me like 3 days to get mine to completely dissolve. Lillian thinks she did in sixth grade. It's kind of a neat little trick. You definitely probably will not want to eat the egg afterwards, though. So make sure it's okay with your parents. Excuse me. All right. The next one is lavender. Now, in this case, I used lavender bubble bath soap. I bought at Walmart. I didn't actually have it at my house. To me, it smells like a garden. Very very pretty smell. So I saw some of you weren't able to get lavender, but you'll find lavender in a lot of bath products because Lillian says of sleeping. A lot of people put actually lavender in their pillows because it's very relaxing. It's soothing. It's a calming smell. If you are a believer in essential oils, it's supposed to relax you. So of a meadow, yeah. I mean, it can definitely be a meadow. Turn my camera here a little bit so I'm not. That's even worse. I'm now red. Let's see. Let me get my lights back on. I moved my desk to the other side of the classroom so I could have the window to look out, but now it kind of gives me some glare. All right. The next one, lemon juice. Um, Lemonade. And actually, I don't know. This almost smells dirty. Um, I don't know if it was the lemon juice that I was using, but the only thing it really reminds me of all is lemonade. And I'm not a big fan of lemonade, so to me, it's not that great of a smell. Just no lemons. I mean, you get this same kind of smell from lemons. Um, I use lemons a lot when I cook chicken. There's whoops, where did that come from? I kind of fry up my chicken. I make a sauce that I will pour over it, and I put lemon slices on top of my chicken. I put it in the oven. Yeah, lemon cake's not bad. It's pretty good. Smells very citrusy, like yeah, like lemon bars. Okay, and then the last one is menthol. Now in here, I have a paste that is in mine, very very pungent, and I never smoked them, but this reminds me of my mother's cigarettes. My mom, when she was alive, she smoked menthol cigarettes, and that odor reminds me of her cigarettes. I cannot stand the smell of cigarettes anymore. Um, Not that I ever really liked them, but I mean, just I hate that smell. But that's what it reminds me of because I smell that menthol. I think of those cigarettes. Yes, unfortunately, there is a menthol cigarette out there. There's basically two kinds of cigarettes: regular and menthol. Um, yeah, that's what I have right here, Sanish. This is a vapor rub, and that's one thing they do is if you're sick, if you're congested, what some people will do is they get some on their hands and they rub it in the upper part of their chest, this part right here, and it helps break up congestion. So, okay, so reminds you of being sick. Yeah, a lot of times you'd have that when you're sick, so that's a good thing. Well, not a good thing that reminds you of, but so now Avinash asked about the last column. It said, what do you notice about the chemicals? And that, if I come back here and I open up the assignment, um, we had, wow, both my arms just went numb. That's weird. Right back here. Ugh. We come through and we look at these molecules. We have vinegar up here, CH3COOH. So here's a molecule. We have the limonene, which is the lemonade molecule. We have the vanillin, which is the smell that we get from vanilla, C8H8O3. And then we come down into the next section, the menthol, C10H20O, and then the lanolin, or lanolin, and the lanolin acetate, acetate. Excuse me. There we go. Wow, that one got stuck in my tongue a little bit. The lanolin C10H18 with one O, and the lanolin acetate C12H20O2. So basically, all I was asking you to identify is what do you see? What do you notice about all those molecules? Um, and Samuel, when you look at all those molecules, and by the way, good morning, Samuel. I don't think I said good morning to you earlier. Good morning also to everybody else that I missed. What do you notice about all those molecules? Something they might have in common or something that's different about them? Okay, so they're complex. They're actually made from a bunch of different things. Okay, that's pretty good. Um, Morning, Reese. How you doing, sir? Yeah, so, Reese, what's something you noticed about them? No, I hear you loud and clear. Okay, so kind of you were able to smell it pretty good, I guess you might say. Um, Audrey, how about you? Aubrey, are you there? Yes, now I can. Yeah, when you look at those molecules on the molecular handout sheet, what's something you noticed in common about all these? Samuel said that they're complex, meaning they're made of a few different things. They Reese said that they give you a strong odor when you smell them. What's something else that you might notice? Okay, so the oxygen molecule is kind of lacking. There's not very many oxygen molecules. Vedant, that's okay. There's Cox is having some problems with their internet today. I'm aware of that. So you might want to come back and look at what you missed, but we've just basically been talking about the smell lab. Okay, and one last one, Rashil. Okay, yeah, and if you actually look at them, every molecule there, I believe, let me make sure I'm not lying to you, is composed. Oh, lemonade doesn't have any oxygen, but they're basically, with the exception of lemonade, all carbon, hydrogen, and oxygen. They all have a lot of carbon and hydrogens. These are what are called organic compounds. I don't know if I talked to you about that last time we looked at the molecules, but organic chemistry is based on carbon compounds. And these are all carbon based compounds. If you notice that carbon kind of runs through the center of all these molecules and everything's kind of built off the carbon. One of the reasons is where carbon fits on the periodic table. Let me see if I can pull something up real quick. I think it's called P chart. Um, no, that's not the right name of it. Hold on. Periodic table. P table. Okay, I was close. Not really. Okay, so you can all see this periodic table that I have up on the screen, hopefully. So this is really kind of a neat website right here, ptable.com, because I can click on an element and it will give me all kinds of information about it right over here. Things that you are not ready for necessarily in seventh grade, but like when you get into physical science and you get into chemistry, there's a lot of very interesting stuff here. But what I want to bring to your attention right now, and this is kind of outside of the scope of what we're supposed to be learning about. So this might shoot over some of your heads. Other ones of you might figure this out or get it really pretty easy. Atoms join other atoms based on what's called their outer layer of electrons. And this layer of electrons are called valence electrons. Now, the maximum number of valence electrons an atom can have is 8. It'll never have more than 8 valence electrons. So these guys over here in this last column, these are all valence electrons, and they basically all have 8 electrons in their outer ring, 8 valence electrons, so they will never join with anything else. Now, I say the word most of them. There is an exception, and that's helium. Helium only has 2, but that's the maximum number of electrons helium can have. It can't have any more than 2. It can never have more than 2 electrons, period. Just that's the way it is. So you'll never find helium, neon, argon, krypton, xenon, radon, and oganesson joined with any other elements on the periodic table. All right. Let me come back here and make sure. Nope. Electrons are negative, protons are positive, and neutrons are neutral. I really, really, really wish I could teach you more electron theory or atom theory, but I'm not supposed to anymore. I'm actually going above what I'm supposed to be teaching you right now, but I think you guys can, for the most part, can handle this. Okay, so if these guys have 8 and they don't join anything, this periodic table tells us a lot of other stuff. And it's kind of neat. Anything in column number 1, they only have one valence electron. So they are willing to share it, and they will actually react violently to share that electron with something. So if I were to drop, let's say, sodium in water, it reacts very violently. It produces a gas and will actually cause explosions. So will lithium, potassium, rubium. Everything except for hydrogen is very, very reactive. It does not like to be around water. They'll all explode, very dangerous elements. Column 2, they all have 2 valence electrons. They are still a little bit violent, but not quite as violent as 1. They react very quickly with something else. They want to join something else. You normally do not find either one of these elements in nature by themselves because they want to get rid of that second electron. And when I say get rid of, it means to join with another element. Now, who wants to take a wild guess how many valence electron 3 has? Column 3. 3. But that's where it kind of stops, because from 3 all the way over to 13, and that's kind of an easy way to remember it, 3 to 13, these all have 3 valence electrons. 3 to 13, they all have 3 valence electrons. You can find these materials in nature by themselves, but they easily make compounds. Then we get over here to 4. They have 4 valence electrons. 5 has 5 valence electrons. 6 has 6 valence electrons. Excuse me, column 14 has 4. Column 15 has 5. Column 16 has 6. Column 17 has 7. And then column 18 has 8. Well, the thing about carbon you'll notice is it has 4. So that means it could bond up to 4 different times with other elements. That's why you'll often see carbon bonded in the center of a chain, because it will allow the most bonds of any atom. Maybe a little bit confusing, but does that kind of make sense to you? So you guys know a little bit about stuff. You got halogen alkalides. Those two usually bond together. Very good, Bowie. Active gases, stable, active gases. The stable gases are the noble gases. 8, yeah, noble gases are very stable. Okay. So anyhow, that was kind of a little above and beyond what I normally am supposed to be teaching you nowadays, but I like to teach that. I think it's important to get a little bit of a taste of what you're going to be running into 8th grade and what you're going to run into 9th grade with that. So any questions? So actually, let me come back. So what you were supposed to do with the document here is, so in the second column, you're going to tell me, what do you notice when you smell it? What does it remind you of? But obviously, you don't all have access to all the odors. So this is why it's not a graded assignment because you don't have all the different things to smell. If you were actually in the school and I provided you with all 5 of them, yes, it would be a graded assignment. And then what do you notice about the related models? That's where I just basically wanted you to come through and tell me those things that we just talked about. One, carbon is the base of all these elements. They're complex uh, compounds, meaning they're multiple different items. Most of them have just a couple oxygens, if any at all, but there's a lot of carbons and hydrogens in comparison. Make sense? Okay, so Friday, excuse me, not Friday. Today, actually, and Friday, because Friday is an A day. Remember, Friday is an A day, not a B day. Um, I had hoped on starting an observation lab for you, but we are debating right now if we're even going to do this lab. Just for the simple fact that, wait, hold on just a second. I'm reading what Alexa wrote. Is there a reason why they are put in that order, the model, or are they put in randomly? When you talk about order, Alexa, are you talking about um wait, what, Angelina? Okay. So Alexa, oh, how they're structured. How they're structured is based on the ability of atoms to accept other bonds. One thing about oxygen and carbon, a lot of times these are what are called double bonds. So not only has it's not only sharing one electron, sometimes they're sharing 2 electrons. Really, that was ah, I got you now. I see what happened. Oh, that's funny. Uh, so that's why you have to say, "Hey Google," to get Google to operate. See how many people's Google I just set off. Um, it is set up based on the bonding of the atoms. Let me just put it that way. So, Vedant, what happened is when I asked Alexa a question, somebody's Alexa device started talking. So, does that kind of answer your question, Miss Guzman? Alexa, does that kind of answer your question? So now I have, because this was kind of funny that happened, I got to ask this question of you, ma'am. Do you have an Alexa? Sure, mom. What do you want to? Okay, I'm sorry. I had to ask that question. Um, okay, so as far as today, we've wrapped this up. As of right now, I'll come back to you in just a second, Jesna. As of right now, it looks like Friday is going to be a work on a genius hour day. Because if we don't get the materials we need for this lab, we can't go forward with it. I'm hoping still to wrap up this unit um, Wednesday of next week, and then we move on to a new unit that deals with photosynthesis, cellular respiration and how matter and energy move through an ecosystem. So we're pretty much done with the bath bombs. So that's where we're at with that. Jesna, your question, ma'am? All right. No. Because we're dealing with some acids, so I can't have you using the acids, not without direct supervision. Yeah, but no, I'm sorry, because if you are doing a lab that deals with acids and something happens, I'm actually responsible for it. So, well, while your parents are there, I mean, it's a slippery slope, and it's not an exciting lab, anyways. We might actually be skipping it altogether. We're going to be making that decision here next period. I'm going to get together with the other science teachers and see. Okay, the way the Genius Hour works is you get to pick a subject that interests you. So you get to do it on pretty much anything that you want, as long as it's school appropriate. So I will put up the criteria on Friday, but typically I want you to do something that is interest to you, and I'll ask you, why is this interesting to you? How might this help you in the future? Things like that. I've had people do things on, let's say, essential oils because they're interested. Do essential oils really help people? I've had people, do it on cars because you're getting to that age where you may or may not be driving in the next 3 to 4 years. So what kind of car would you possibly want? If you can justify why you're doing it, if I've had, I think some of you here in this class did it on computer programming because that's something that you're interested in doing in the future. You know, well, that's more of a book report. Um, Maybe the subject of the book, you could do a little research on the subject of the book that you're doing. Yeah, I mean, it's not necessarily a book report, but I want you to investigate something that you're interested in. Does that kind of make sense? And a lot of times, too, what happens is, well, let's just say you're reading a book right now and you really like the book. Okay. What about the book do you like? So maybe there's something in the book that you can, explore. That's a possibility. And what's your third question? It was. We're going to have 3 Friday A days in a row. And I really don't know. There's not a lot of teachers here who are very happy with the Friday being an A day, just for the simple fact that we're losing time with our B days. Um, it's not that I don't like my A day classes. I love my A day classes, but just I'm not getting the same amount of classroom time. I think a lot of it has to do with the fact that Monday is a holiday. So there's no school on Monday. And that should have been an A day. So they're making Friday an A day for that, but then we have an unbalanced number of A days and B days. But we talked to the school district. They were not willing to change it. So that's just what it is. that is something that has been done above my pay grade. I just have to accept what they did. All right. So, ladies and gentlemen, we are done for the day. Yes.